This section we're going to talk about log functions, or the long version is logarithmic functions, but usually referred to as just log functions for short. It would be a function that looks like this, and so you have log, and that's the function, and then x is actually the argument. We call that the argument. And then this little number, this little subscripted number here, is called the base. Now the base can be any number greater than 0 as long as it's not equal to 1. And the domain of your log functions is all real numbers that are greater than 0. So not all real numbers, but just all real numbers greater than 0. So x can be any real number greater than 0. Okay. So here's a couple of examples of logs. So let me show you how you read this. I would read this as the log of x base 3. So this is the log of the argument x with the base 3. And then this would be the log of x base 1.5. Now, I tell my students, in order to understand a log, we need to connect it to something that we're familiar with, and that would be exponential functions. So to help you understand a log, it's important for you to memorize this relationship. If you have a log equation like this, where y equals the log of x base a, understand that that means the same thing as stating a to the y equals x. So what that means is that when you evaluate the log of some argument x base a, what that gives you is that gives you the exponent y, such that when you raise a to that y value, it gives you x. So the result of a log just gives you an exponent, and so it just answers the question, a to what power equals x. So if you go back up here, if I put in, say, a number, I don't know, just say a number 9, then the result would be 3 to what power equals 9. Now that would be an easy one to answer because 3 to the second power equals 9, so the log of 9 base 3 would be 2. But if you put in some other number like 37, then you say 3 to what power equals 37. Well, that's a little bit more complicated to figure out, and we'll talk more about that later. But now, as far as this relationship here, it's good to practice on some statements. So I'm going to give you some statements that are true, and you're going to show me why it's true in exponential form here. So here I'm going to tell you that the log of 100 base 10 is actually 2. And then if you write this in its exponential form, you'll see why that's true. Because in exponential form, this log statement would be written as 10 to the second power equals 100, which of course you know is a true statement. Now the second example, I'm telling you that the log of 1/25 base 5 is negative 2. And if you write that in exponential form, you can see why it's true, because that would mean that 5 to the negative 2 power is 1/25. And this one might require a little bit more depth to determine, but you can easily figure this out, that 5 to the negative 2 is 1/25. Now here I'm just giving you expressions. So I'm going to tell you that the log of s plus t base b is r. So in exponential form, that means that b to the r must equal this argument s plus t. So b to the r equals s plus t. Now likewise, I can give you exponential forms that are true, and you can write that in log form. So 7 to the third power is 343. You can easily verify that. So that would mean that if I took the log of 343 base 7, the result should be 3, because 7 to the third power is 343. Also, 1 over 1,000 is equal to 10 to the negative 3 power. So that means that if I took the log of 1 over 1,000 base 10, that should equal negative 3, because 10 to the negative 3 power is 1 over 1,000. And then this b to the 0 would equal 1, that would be the same as saying that the log of 1 base b is 0. And again, because b to the 0 does equal 1. Okay. Now, some basic log graphs. So if you wanted to graph the log of x base 2 and you didn't have technology to help you, then what you could do is you could write this as, first of all, think of this f of x. Think of it as y instead of f of x. And then you could say, okay, y equals the log of x base 2 is the same as saying 2 to the y is x. So just put it in its exponential form and you'll get x equals 2 to the y. Now, so if I want to graph this, it's going to be easier to pick y values and get the corresponding x. So I'm going to pick y values. So I'm going to let x, I'm going to let y be negative 2. And then when I raise 2 to the negative 2, I'll see that x is 1/4. And then I'll do the same thing for y is equal to negative 1. So when y is negative 1, 2 to the negative 1 is 1/2. And then when y is 0, 2 to the 0 gives me 1 for x. And then when y is 1, 2 to the 1 gives me 2 for x. And when y is 2, I get 4 for x. So if you plot those values, 1/4 negative 2 would be this point. 1/2 negative 1 would be this point. 1, 0 would be this point. 2, 1 would be this point. 4, 2 would be this point. And you can see that you'll get a graph that starts down here low, comes up through here, crosses the x-axis at 1, 0, and just sort of bends out through here in this direction. And that's your basic log graph. Now, if the base was a number less than 1, like 1/4, then you could say, well, that's the same as saying 1/4 to the y equals x, or x equals 1/4 to the y. Now, in that case, if you let y be negative 2, x would be 1/4 to the negative 2. And remember, I showed you this earlier when we did exponential functions. 1/4 to the negative 2 is the same as 4 to the positive 2, which is 16. Then if you let x be negative 1, if you let y be negative 1, then x would be 1/4 to the negative 1, which is 4. If you let y be 0, then x would be 1/4. If you let y be 1, x would be 1/4. If x is 0, y would be... If y is 0, x would be 1. If y is 1, x would be 1/4. And if y is 2, x would be 1/16. And so if you plot those points, I can't fit them all on here, but if you go over here to say, let's see, I have 1, 0 there. All right, so if I go out here to where x is 4, go over here where x is 4, y would be negative 1. So that would be about right there. So when x is 4, y would be negative 1. So that would be, there'd be a point right there, which would be the point 4, negative 1. I probably should have put that on the graph. All right. Okay, and then you have the point 1, 0, and then you also have the point where when x is 1/4, y is 1, and you have the point where x is 1/16, y is 2. So you can see that the graph goes in this direction here, so it just kind of flips about the x-axis and goes down this way. Whereas up here, see, this was an increasing function, and then here, when the base is less than 1, the graph is a decreasing function. Now, if you increase the base, this graph was the log of x base 2. If you increase the base, and let's say you make it log of x base 5, you still get a similar graph, but it flattens out a bit quicker. So here, if you write this in the form 5 to the y equals x, then when y is negative 2, 5 to the negative 2 is 1/25, so that'll give you a point like maybe right here. And then when y is negative 1, 5 to the negative 1 is 1/5, So you get 1/5 -1, which might be right here. And then at 1, 0, and when y is 0, x is 1, so you would get this point. And then when y is 1, x is 5, so you get to 0.51. And then when y is 2, x would be 25. So you wouldn't get to y equal 2 until you were way over here somewhere. But you can see it's very similar to the graph of log of x base 2, but it just flattens out a little quicker. So just like I did with exponential functions, I'll mention some transformations here. You know how to graph log of x base 2. So if you wanted to graph minus log of x base 2, you would simply shift or reflect that graph about the x-axis. And then for the plus 2, that would just shift the graph up 2 units. So to get this graph, you would take the log of x base 2, reflect it about the x-axis, and shift it up 2 units. Now if you wanted to graph this graph, this is based on the graph of log of x base of 4th, which I just graphed. So if you replace x with negative x, that's going to reflect the graph about the y-axis. And then the 3 here that you're multiplying by the function, that's just going to stretch the graph by a factor of 3. And then this last one here, for log of, this would be based on the log of x base 5 graph. The x minus 2 here, that would just shift the graph 2 units to the right. The 1/3 would shrink the graph by a factor of 1/3, and then the plus 3 would shift it up. And so that's how those operations affect the graph. So that's all I'll talk about on this video. In the next video, I'll talk about the properties of log functions.